In this video, we're going to be looking at the Fahrenheit and Celsius temperature scales. And we start by talking about just the relationship between these by looking at the freezing points and the boiling points of water. That when you freeze water, a frozen ice cube in the Fahrenheit scale is 32 degrees. And water boils at 212 degrees. Although here at 5,280 feet above sea level, it actually boils a little cooler than that. But at sea level, 212 degrees. So the change from the freezing to the boiling point is a change of 180 degrees. The Celsius scale uses the freezing and boiling points of water to determine its low and high points. So on the Celsius scale, water freezes at 0 and boils at 100, making a change of 100 degrees. So knowing just those couple of reference points, we're going to see if we can determine which of these three temperatures is the most likely one for a freezer. So if we're looking at a freezer, and the choices that they're giving us are a negative 18 degrees Celsius, 5 degrees Celsius, and 32 degrees Celsius. Well, if we want our freezer to actually keep things frozen, our temperature in the freezer would need to be below the freezing point, which is 0 degrees Celsius. And the only option we're given that is below the freezing point is this negative 18 degrees. When we're talking about a comfortable temperature for our house, they give us 21, 50, and 68 to guess from. So looking at these three temperatures, 50 is our halfway point between freezing and boiling. So the halfway point between freezing and boiling on the Fahrenheit scale is somewhere near 120 degrees, which would be pretty uncomfortable in a house. 68 degrees is even hotter than that. So it's more than 120 degrees. So that leaves us with 21 degrees as our most reasonable household temperature, which just happens to be pretty close to 70 degrees on the Fahrenheit scale. So now that you have a little bit of an idea of the reference points for Celsius and Fahrenheit, let's talk about how you would convert back and forth between those two scales. So we talked again that the change in the temperature between the Fahrenheit freezing and boiling point, the Fahrenheit scale has a change of 180 degrees, where the Celsius scale just has a change of 100 degrees. If we look at that, at those two values as a ratio, the ratio between 180 degrees and 100 degrees, that would reduce down to a ratio of 9 to 5. Or, if we were comparing them upside down, the Celsius compared to Fahrenheit, it would be, Celsius compared to Fahrenheit, it would be in a ratio of 5 to 9. So that's one thing that's different about the two scales, the size of each individual degree. Fahrenheit degrees are much smaller than Celsius degrees. The other thing that's different is their starting point, that the Fahrenheit scale starts its freezing point at 32 degrees above 0, whereas the Celsius scale starts its freezing point at 0. So if we were going to write formulas that would allow us to convert between these two units, our Celsius, to determine Celsius, if we're given Fahrenheit, we're going to have to first take whatever that Fahrenheit temperature is and subtract 32 from it. And then after we've subtracted 32, we're going to multiply by that ratio of 5/9 to turn it into Celsius. If we're starting with Celsius and we want to convert to Fahrenheit, we're going to have to take that Celsius temperature and multiply it by the ratio 9/5 to get each of those degrees turned from Celsius degrees into Fahrenheit degrees. And then we also need to add 32 more degrees to account for this adjustment to the 32 degrees for freezing. So let's try two examples of that. If we're converting 86 degrees Fahrenheit to Celsius, we're going to use this formula here, where we can put 86 in place of the F, and then use order of operations to solve it until we figure out the Celsius scale. So we have C equals 5/9, and then our Fahrenheit temperature, which is 86, and we're going to subtract 32 from it. Following order of operations, I'll do what's in the parentheses first. That gives me C equals 59, or 5/9 times 54. Then to do this multiplication, I'm going to put a 1 under there and do some cross-canceling. The 9 will cancel out, and I'm left with a 5 times 6. So 86 degrees Fahrenheit is the same as 30 degrees on the Celsius scale. Going the other direction, looking at a Celsius temperature and converting it to Fahrenheit, I'll start by placing the 3 in my formula where the C used to be, and then following order of operations. In this one I need to do the multiplication before I do the addition, because that 32 is not in parentheses with the C like it was over here with the Fahrenheit. So I'm going to put a 1 under that 3. There aren't any like terms to cancel, so I end up with 27/5 plus 32. And because of the context, because we're talking about degrees, and it would be kind of weird for them to give you a temperature in fraction form, I'm going to go ahead and turn this fraction into its decimal form. So 5 will fit into 27 5 times with 2 left over, and that 2/5 that's left over is the same thing as 4/10. Maybe I should put the math for this down below. 27 divided by 5 is the same as 5 and 2/5. And that 2/5 is the same as 4/10. And I can write the fraction 4/10 as a 0.4. There's your little aside for that. And then 5.4, when I add it to the 32, is going to give me a total of 37.4 degrees for my Fahrenheit temperature.